Hello guys, welcome back. Welcome to this IOQM session, and we have discussed last day till. Just give me a moment. We have discussed last day till question number 7, geometry problem. So today we'll be taking this opportunity. We'll be taking this opportunity out to discuss this rest of the problems as of now. Okay, so let's question number 7, geometry problem. Let's start. So today we'll be taking this opportunity. We'll be taking this opportunity out to discuss this rest of the. Okay, so let's wait for some students to join. So as you know, in this session, we will be discussing a very detailed version of the high school mathematics IOQM problems. Not the solutions, but how to think about them. So that's really important for you guys. So yeah. Okay, fine. Okay, so let's start. The problems. So let's do this problem number 8. Okay. Uh, Good evening. Good evening. Yeah, I think there are a few people over here because maybe people are not interested in like discussion since the exam is all over. Okay, so but we'll still complete this over here. Hi Ayush, hi Ahana, hi Saradip. So we'll be completing these solutions. Let's discuss the solutions one by one. So a 5-digit number in best 10 has digit k, k plus 1, k plus 2, 3k, and 3k and k plus 3 in that order. Okay. I hope you understand the problem. I'm very good, Amitya. Hi Sonali. Yeah. So let's do this. One second. So if you think about this problem, guys. So first of all, the basics required for this problem are what is a best number, like how do you write a number in best 10? You know about that, right? Decimal expansion, that is what is called best 10. In general, it can be written in best b, okay, any best b. So 5-digit integer in best 10 can be written like this. So let's take this example. So here it's given like it's 5. So 1, 2, 3, 4, 5. This number is same as, I hope you know about this, 5 into 10 to the power 0, or rather like 2 like this. What is happening over here that consider the 0 place, 1, second, third, and fourth. Okay. So just multiply 10 to the power 0, 10 to the power 1, 10 to the power 2, 10 to the power 3, and 10 to the power 4. Okay, and if you add it up, so what you get over here? You get 5 into 10 to the power 0 plus 4 into 10 to the power 1 plus 3 into 10 to the power 2 plus 2 into 10 to the power 3 plus 1 into 10 to the power 4. So you get this number, okay? So let's use this same idea over here, guys, to solve this problem. Yeah. Yeah, we have to see the expanded form over here. Let's use this idea to solve this problem, guys. So here instead of this numbers, it's given k, k plus 1, then k plus 2, then k plus 3k. Sorry, it's 3k and it's k plus 3 over here. Okay, 3k and k plus 3. So observe 3k is there. So what does it really mean? It means that 3k is a digit, right? So therefore 3k must be less than or equal to 9. Okay, so it implies that k must be less than or equal to 3. That's an important idea. K must be less than or equal to 3. Okay, sounds good. Yeah, these things are covered in high school mathematics part. So this is part of number theory. So yeah, part of high school mathematics. So k is less than or equal to 3, and this is called number basis. Okay, in number theory. And observe that if k is less than or equal to 3, so we can have all this opportunity, we can check all these numbers over here. Okay, we can check for k is equal to 1, for k is equal to 2, for k is equal to 3. Okay, what is really happening? And if this number, so let's try it over here. So observe this one thing: if k equal to 1, the ending digit is 4. If k equal to 2, ending digit is 5. Okay, if k equal to 3, the ending digit is 6. And here it will be, so it's 4, 5, 6 is the option. Here it will be 1, 2, 3, 2, 3, 4, 3, 4, 5. Okay, and here it will be 3, 6 and 9. Okay, this three stuff. You can observe over here that this first and second cannot be a perfect square, because this is a even number, and observe that this is not divisible by 4, because 34 is not divisible by 4. Okay, so if it's an even number, it must be divisible by 4, and since it's a perfect square, so this cannot be a perfect square. Similarly, 20, it should end with 25 to be a perfect square. Okay, if it's ending with 5. Okay, so it's this is not a perfect square. Okay, since it's divisible by 5, but it's not divisible by 25. So therefore, this must be a perfect square. 3, 5, 9, 6. Okay, so this is the entire idea over here. Okay, yeah. So yeah, why k is equal to, like, k is less than or equal to 3? It means that because each digit can be at most 9, right, Amit Malik? So therefore its k is less than or equal to 3, because 3k must be less than or equal to 9, so k must be less than or equal to 3. I hope you understand this. Yeah, so that's the idea, essential. And what we get over here is the following. Oops. Yeah, so what we get over here is the following. We get that this is the perfect square, and if you just square root it, you will get the m. Okay, you look at the RAM, you can sum up it. So square root, this is not really a problem. So all of you understood the problem. Let's see what is the answer. Yeah. So I think it will be 186 square. This is 186 square, and therefore its sum is 15. Okay, that's the idea. So even if you are not, even if you are college students, these problems will make sense if you are preparing for ISIM start. High school mathematics part, it will make sense. Okay, so yeah, so this is really important stuff. So let's move to the next general let's next problem. Okay, let's next problem. The next problem asks you about that. So it's this problem revolves around a bit of geometry. So these are like bit of drawing. Now, like, you have to draw the stuff. Okay, that's always the first hint. So ABC is a triangle that AB is equal to 5, AC is equal to 4, and BC is equal to 6. The internal angle bisector of C intersects the side AB at D, MN, and N intersects the side at intersects the sides on, okay, at D and MN are taken positive sides, so that DM is parallel to this and this is parallel to this. If MN square is equal to this, then so essentially you have to find the corresponding. Yes. No, let's not go into the answer, Sarthak. Let's see how we should approach this problem. So you have to understand that how you should find this mn square. So before that, you must draw it. So how to draw this problem, guys? So let's try to just draw it. Okay, there is nothing called how to draw. So let's try to draw it and observe that this is how it should look like. So let me draw it. Okay, so and this is AC, this is BC. ABC over here. AB is equal to 5 and AC is equal to 4. Okay, and BC is equal to 6. You know that. Perfect. And okay, so we draw the internal angle bisector of C, which meets at D over here. And we draw N and M such that, okay, perfect. Sounds very good. So we draw this M and N such that this is parallel to this base and this is parallel to this base. Okay, perfect. So we have got this is parallel to this base, and this is red thing is parallel to this. Perfect. So you know this is angle is also equal because it's an internal angle bisector. So we need to find this. Okay, this is N and this is M. So we need to find this one. Okay, we need to find this one. Okay, so let's try to understand how to approximate the how to approach this problem, guys. Okay, first of all is that um let's see. So if you see, first observation is that just from the given condition, okay, we are not doing any construction, that dncm is a dncm is a parallelogram. Okay, dncm is a parallelogram. If dncm is a parallelogram, and observe that it doesn't happen always, okay, that in a parallelogram the angle bisectors are bisecting each other. I mean, sorry, the diagonal is bisecting the angle bisector. Okay, this also means this is also the angle bisector. This is same actually. Okay, this too means this is isosceles. Okay, this side is equal to this side, which is equal to this side is equal to this side. So which means that it's actually dncm is a rhombus. Is a rhombus. Okay, because all the sides are equal. Okay, all the sides are equal. So how do you approach next? How do you approach next? So observe that mn. So therefore it just implies that mn and the diagonals of a rhombus are perpendicular to each other. So mn is perpendicular to dc. You get these properties just like that only. Okay. So we need to find mn. So how you should find it? That's the idea. How you should find it. Okay. So how you should find it? That's the idea. So think about it. So if you understand this very carefully, that what are the information you have been given. Okay, so I think I have told you enough about this. When there are information about sides, if you remember how I have given you the example here, if the information about sides only, what did you do? You did similarity, right? Or you can use trigonometry, sine law, cosine law. So there are two opportunities here, so therefore you have to find out similar triangles over here. Okay, or you have to use the information on the side. I've always told you the method of how to do it. Stewart's theorem is there, angle bisector theorem is there, similarity, they are all based on similarity. Okay, even if you don't remember the theorem, just try for see for similar triangles. Okay, and rather like what are the triangles over there? Okay, that's the idea. Okay, so try to look for similar triangles. So how do you do it? Okay, so first of all, the idea is that let's so you don't know this corresponding side, so let's call it x. Okay, let's call this side x, 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 and x. Okay, observe that since this is a parallel, so this angle must be equal to this angle. Okay, this angle must be equal to this angle. Similarly, so there's a lot of parallel. This angle must be equal to this angle, and similarly, this angle must be equal to this angle. Okay, so this is the idea. Okay, so lots of like parallel lines over here. It's 5 over here. Okay, that's the idea. So think about this now. Think about this now. How will you do it? So first we will try to understand this result, that first of all ADN and ABC are parallel, right? ADN and ABC are parallel. Okay, so we need to find MN. Okay, we need to find MN. So don't worry about that. Okay, so we can find one. Suppose the idea is that if we can find two of these sides now, and this angle maybe, then we can easily find this by cosine law. Okay, that's the idea. Or sine law. Let's see. So once you know the sides, you can easily find out by the trigonometric form that on the angle, sort of cosine of the angles or trigonometric functions of the angle, you can easily find out that corresponding. Yeah, you can use angle bisector theorem. You can use angle bisector theorem to get AD by this is equal to this by this. Sure, you can use. Surely can use. So you know that this is sort of what ratio they are in. Okay, AD and BD. Surely you know that. Perfect. So therefore we have to formalize it. Okay, you have to formalize it. Yeah, you're right. So let's try to find x first. Can you find x? So you have to find x first. Can you find x? How can you find x? Which triangle you should take to find x? Because you don't know about x, right? You need to use the triangle to find about x. How will you find it? Think about it. So which sides you should take rather to find x? So suppose let's take this example. So you use that ADN, triangle ADN is similar to triangle ABC, okay? It's similar to triangle ABC. So how will you use the x? So you know that x is same as what? DN, right? So DN, right? So what is this side? This is x, so this is 4 minus x, right? So you see, you have this x over here, you have this x over here, and in this big triangle you have 4 over here and 5 over 6 over here, right? So 4, 6, and you have this 4 minus 6 and x over here. So you can use this opportunity. So dn by bc is same as n by ac, since this is similar. And you get that dn is x by bc is 6 and an is what? 4 minus x and AC is 4. So if you solve this out, you will get that x is equal to 2.4. You see how we approach this problem? We need to find x. So we have understood that x is equal to 2.4. Let's move this all this stuff. Oops. It's over here. Okay, so we have got that this is equal to 2.4. This is maybe equal to 2.4. This is 2.4 and this is 2.4. So you know about this 2.4 sides now. Therefore, you know this side. This is 1.6. Since this is 2.4, this is 3.6. Okay, let's use all the information you have got over here. But you don't know about this side, right? You don't know about this side. But you know that which ratio it can be in. You can use angle bisector theorem to find this ratio out. Okay, but do you need that? What do you really need? So can you find so observe that, can you find this angle now? You don't need to find using angle bisector theorem. Can you find this angle C? Cos of C. You can use the cosine law in the big triangle, and you can use this. Now you know these two sides, right? You can use this now to find this corresponding side, okay? So let's find out cos C, okay? Cos C is what? In a triangle ACB, if this is A, this is B, this is C, then cos C is what? C square minus A square minus B square by twice AB is an cos angle C. So it's here, C square means 5 square, 25 minus 4, 24 minus 16 by twice 4 into 6, that is 48. This is cos C coming out. If you see this cos C coming out, you get what? If you find it out, you will get, am I doing something correct? I think I did something wrong maybe. Yeah, I think it's, yeah, it will be a square plus b square minus that. And you will get it same as, let's see, I think you will get same as 9 by 16. So you have got 9 cos C. Now take the small triangle. Let's say P over here and P over here. You need to find this. I'm telling this now. I'm telling this is big stuff now here. This is small stuff over here. If this is cos C, then you need to find this for an isolated triangle. It's twice P square minus twice P square cos C, which is twice P square times 1 minus cos C. So you get twice P square is 2.4 whole square, and you can get it from here, cos C1 minus 9 by 16. So you can get it from here easily. Okay, so therefore this is the idea, okay? Yes, so this essential idea also you could have found, but the idea is that you could have also found out by no, I think it wouldn't have helped maybe, because you need to go towards the aim. What is you required to find, okay? Yeah, I need to find. You can also do it like that, Sarthak. Yep. You can also do it like that. Anyways, let's not wait. Devote more time to this. let's move on to the next problem. I hope you're understanding how to do this. So as I have told, you need to use similarity to always get about new information of the sides. Okay, that's what we did over here. Use similarity to get new information of sides when lots of sides are there. Okay, that means that, I mean, you can use similarity. Essentially, if you see angle bisector theorem, it's similarity. If you see Stewart's theorem, the like, or Cevian theorem, like finding the length of the Cevian, is essentially all about similarity. Okay, or sine law, cosine law. So you have to use one of them always. Okay, otherwise it doesn't make sense. So remember all when you are doing this, solving problems like this, remember this, what are the methods you have in your arsenal of solving problems to understand how you can approach this. Okay. Okay, so let's see. I think the next problem of test 10, I think that's a mean problem. Let's see. Okay, let's do this one. It's a very easy problem. Let's see. Mean problem. Okay, 5 students take a test. Okay, 5 students take a test on which integer score is only allowed 0 to 100, inclusive of all possible, both of them possible. What is the largest possible difference between a median and the mean of the scores? Okay, this is a really interesting problem, but I think it's an easy problem. So largest possible difference between the median and the mean. 5 students are there, A, B, C, D, E. So let's say these are all like ordered in this manner. Okay, A less than B less than C less than D equal to. Okay, therefore what do you get? You get C is the median score, right? 5 students are there, and what is the mean? Mean is A plus B plus C plus D plus E by 5. This is the mean, right? So how can you make this? So what is the maximum possible mean possible? The maximum possible mean is possible 100, right? But then also the median will be 100. So observe that if you fix the mean, if you can fix the median over here, okay, and then you can use larger numbers over here to manipulate the mean. Okay, you understand? You can fix the median over here. It's asked between the difference of the median and the mean, right? So suppose the median is C, say. I don't know what is C. So what you can put B and A both to be C minus 1 and C minus 1. And what you can put D as 100 and 100. You see? Then it will be the maximum mean, right? You have reduced the A and B to the maximum possible before C, or maybe you can consider it as C also. Yeah, they can be C. I'm so sorry. This can be C. This can be C. Okay, and this can be 100. So what is the maximum? So given C is the median, what is the maximum possible score of the mean possible? That is this number. That is C plus C plus C plus 100 plus 100. And if you divide by 5, you get it, right? So this is the maximum possible mean max, which is a function of C. Okay, when the median C is given. Okay, and therefore what you get is over here, that's for C median, you get this. So let's compute this. What is happening over here? It's 3C by 5 plus 240. Okay, so let's compute the difference, the modulus. Okay, so C minus 3C by 5 minus 40. Okay, and if you take this, you get that 2C by 5 minus 40 is the positive stuff. So all of you understanding the method over here, guys? Yeah, this is called extremal principle, guys. Okay, this is called extremal principle. Observe this very carefully. What is the median? The median is the mid score. Okay, so if C is the mid score, okay, you need to maximize the mean, right, from C. You have to maximize the mean from C. Okay, the mean can be the lowest mean possible is 0 0, and this is C C C. Okay, or this. So let's take two cases. Okay, there can be two cases now. Try to understand it very carefully. So three numbers are like, the numbers are like this. Okay, we know that the median is C. Let's assume the median is C. It's not assume that the median, we can understand median is C. Let's see the two extremal mean. The max mean The max mean we have seen when which can happen only if this is maximized before C, and this is maximized after C. That is, A is equal to B is equal to C, and D is equal to E is equal to 100. So we are trying to maximizing this. Okay, the minimum possible mean is, let's see, mean. The minimum possible mean is what? When 0, 0. So A is equal to B is equal to the minimum possible 0, 0, and D is equal to E is equal to C, the minimum possible mean. Okay, this is the idea. So therefore here you get mean is 2C by 5, and here you get 3C by, sorry, not 2C by 5, it's 3C by 5, and you get 3C by 5 plus 40. Okay, so these are the two means you get, and you see got the median C. So the positive difference between this and this, we are getting the following. It's modulus of 2C by 5 minus 40, and here it's modulus of 2C by 5. So these are the two numbers we are getting. Okay, so we have to maximize the elements of these two numbers based upon the value of the number. So this is a really interesting problem. I like this problem out. I really like this problem, how it's done. But I mean, maybe people have done it in a much more experimental framework, but you can understand over here what is the maximum possible idea over here. So observe that what is the maximum possible value of C? It can be 100, right? If C is equal to 100, what do you get here? You get 0, right? It's not really happening. So if we can plot this graph, I think we can sort of, essentially what we are wanting is that we wanting this, the following. We wanting, so these are two functions of C, right? So let's try to plot these two graphs. This is a really interesting problem. Like if you want to plot this graph, observe this is actually 0 when, so let's find out 2C by 5 minus 40, where this graph lie. So if you just find out this, y is equal to x, 2x minus 40. So if you add 0, it is minus 40. Okay, and at 100, at 40, sorry, at 100, it's 0. So it's, I think it's like this. So I think it's like this. It's 100 comma 0 is this, and 0 comma minus 40 is this. So this is a line. You need to make it positive. So this is the idea. The maximum is occurring in this here. Okay, but we have not done yet. Observe this very carefully that, so this is a 40 which is possible. So it's modulus we are taking. Okay, and also 2C by 5. 2C by 5. Let's draw this graph. So at 0 it's 0, and at 100 it's 40. So it's just the like this. So these are two lines we have got, and you have to take the maximum of all this, maximum to maximum. So essentially we need to compare this part. So observe that among in this part, the maximum that is possible is 40, and it is occurring in two cases, when C is equal to 100 and when C is equal to 0. Okay, so it's occurring in two possible cases. That is, the distribution is 0, 0, 0, 100, 100. This is one of the cases. Another is 100, 100. Wait. Another is I think another is 0, 0, 100, 100, 100. Is this true? 60. Yes, I think. Wait, no. Let's see. I hope all of you understood the way to do it, guys. This problem. This is a really interesting problem, guys. It's if you want to understand it really, really deeply, I mean, without like trying it out, I think this is an interesting problem. That what is really happening and when it's really happening. Instead, if the question would have come like, consider all the cases and tell the number of cases, find the number of cases, find the number of cases for which it is giving the maximum positive value, then you must have done this. You could have done the problem in a different manner. Okay, instead of this problem, you could have asked that what is the maximum possible, what are the number of cases for which this is achieving the maximum, it is for achieving the largest possible difference, and we have found out is actually achieving two different set of scores. What are the two different set of scores? Here it is happening when C is equal to 0, c is equal to 100, and here it's happening when c is equal to 0. Okay, so observe this, if c is equal to 0 over here, it means that 0 0 0 100 100 is the case over here, and here if c is equal to 100, it means 0 0 100 100 100 is the case over here. Okay, so these are two possible cases. Observe that here the median is 0 and mean is 40, and here the median is 100 and mean is 300 by, that is 60. See, this is a really intriguing problem. I like this problem. Yeah, you're right. But see, the question could have come in a different manner. Okay, then you could have done it. Okay, that's the idea. The question could have come in a very different manner. That's what I told. So that's how change the problem. I could have changed the problem. Okay, that's the idea. But yeah, that's why you need to go in deep into the problem to understand what is really going on. Okay, guys. So this is the idea. Okay, so I hope all of you understood this. Ahana, Tishika, if you are here, I hope you're understanding. Any doubts? Any doubts, guys? So see, this discussion is not just discussing the solutions, guys. Okay, this discussion is just for your future, how you should approach these problems, how you should do this problem. If you see other solutions, I don't know, in the websites, other websites, you will see that just it's told that it's just 40, and this stuff is given that its maximum can be 40. But the question is that when the 40 can occur. Okay, so the question can be different, with question can be very intriguing, question can be different. Okay, so that's the idea. So that I like this question very much. So you can think about this in a general framework. Okay, if it was n students and it was 0 to m, what was the largest possible difference? Okay, you could have done in two different cases. So think about this general problem, guys. So those who are in our superstars batch of Chinta, and those who are not even, we can discuss this problem. Okay, we can generalize this problem that m students take a test on which an integer score is from 0 to m is possible, n is possible. Okay, so what will be the largest possible difference between the median and the mean? Okay, you can ask this problem. It's a really intriguing problem. I like this problem. So Sauradip, I think you can write down this problem and send it to me in LaTeX. I can post it in the corresponding Superstars forum. Okay, I think it's a really interesting research problem. It can be. Okay, let's move on to the different problem. Let's move on to the next problem. The next problem is a combinatorics cum theory of equations problem. This problem is quite possible in ISIM stat. Okay, so IOQM. Okay, so x is an integer set from -5 to 5. Okay, x is a set, and S is a comma b pairs such that both x square plus ax plus b and x cube plus bx plus a has at least a common real 0, a common real root. Okay, so understand this very carefully. X is from -5 to 5, and S is a comma b pair which belongs to x comma x cross x, such that x square plus ax plus b and x cube plus bx plus a have at least a common real 0. So how do you approach this type of problems, guys? How do you approach this type of problems? First of all, you have to assume that it's a real root is there. Okay, you have to first assume that real root is there. So use the information over here. It has a real root. Okay, so you have to algebra over here. Just write when there's algebraic problem, just write it down. So x square plus ax plus b has a real root common with x cube plus bx plus a. So they are equal to 0. Okay, for some x, we don't know the x. We will try to find out the x from this equation. Okay, so this is the idea. So what's next? What's next? How can you approach this problem now? Interesting. Yes, so that's the idea. So you have these two equations, guys. 0 and x is cube plus bx plus a is equal to 0. You can understand over here, if you have multiplied b over here, if you have multiplied, so you could have multiplied x over here and you could have eliminated. But here we are looking for, let's say, so here let's see how we can do it. So we need to eliminate the function. So one way you can do it, we can eliminate this by multiplying x's cube over here and eliminating and finding a x. Okay, so let's try to understand this. So we multiply x to, there are two possible ways. Okay, so let's multiply x's cube plus ax square plus bx is equal to 0, and we have x cube plus bx plus a is equal to 0. One equation. We can now subtract this 2 to get another quadratic equation with a and b. Okay, and then we can find it out over there. So it means the same. So and x is equal to 0 is not a plausible solution because we have multiplied by x. So we can do like this, or we can do it, so we can now subtract this 2 to get that ax square. Oh, see here bx and bx get cancelled. That's really interesting. Okay, minus a is equal to 0. So what you get over here is x square is equal to, okay, here you can get that x, a can be equal to 0, one possible options. If a is not equal to 0, then it gets x is equal to plus minus 1, other roots. You see, if a is not equal to 0, then x is equal to plus minus 1 is a root. Okay, have at least one common root. Okay, so let's see how will you approach this problem, guys. Now, so we get that alpha, that a is equal to 0, or x is equal to plus minus 1 is one of the roots if a is not equal to 0. So what's next? So let's take the case when a is equal to 0. Okay, let's take the case when a is equal to 0. I think I'm doing some problem over here. I'm doing some mistake over here. Some mistake. Wait a minute. Okay, so let's take the case when a is equal to 0. If a is equal to 0, then we get that x square plus b is equal to 0 and x cube plus bx is equal to 0. Okay, so x is equal to 0 is not a common solution. So you get that it must be that x square plus b is equal to 0. But observe over here that in this case times x. In this case, it implies that both have at least one common 0. So therefore, this a is equal to 0 is a solution, common solution. So a is equal to 0 and b is equal to anything. Anything? No, not anything. Because b must be negative. Or like b must be non-negative. So b must be less than or equal to 0. So therefore, we got that a is equal to 0 and b belonging to minus 5, minus 4, 0. There is, so therefore 6 possible solutions over here. Okay, we have got this. Okay, so let's take a is not equal to 0 now. Okay, let's take a is not equal to 0 now. Okay, let's take that. If you take a is not equal to 0, then what do you get over here? A is not equal to 0, guys. If a is not equal to 0, you get what? So therefore, if a is not equal to 0, we have got that x must be here plus minus 1. Okay, if a is not equal to 0, x must be equal to plus minus 1. Let's put that. If x is equal to 1 and x is equal to minus 1. If x is equal to 1, we have got that therefore 1 plus a plus b is equal to 0 and 1 plus b plus a is equal to 0. It's coming up perfectly. Minus 1 is 1 minus a plus b is equal to 0, and we have got that minus 1 minus b plus a, that is same. So we are getting these two equations. Okay, we are getting these two equations which must be true to make at least one of them correct. one of the solutions correct. Okay, so so what we will need over here, so we need to find all those solutions over here, so that a plus b is equal to -1 and a minus b is equal to 1, all the possible solutions. So here a plus b is equal to -1 is what, just fix a, and we have, so a can be, if b is equal to what, b is therefore minus a minus 1. So since b can be at most 5, sorry, b can be at most -5, so a must be at most 4. Okay, that's the idea. So therefore number of solutions is -5 से लेकर 4 for a and similarly for b. So therefore we have 10 solutions over here, and similarly for a minus b, 1 plus b, I think another 10 solutions. So therefore total 26 solutions, I guess. Am I doing something wrong? I think I counted something twice. Yeah, I counted something twice. I counted a is equal to 0 twice, once here and once here. So therefore -2. So because a is equal to 0 is already considered over here. A is not equal to 0 wala case hai ye. So -2. So therefore you get 24 options. Okay guys, any doubts? Any doubts guys? Ahana, Tishika, are you understanding? Yeah, perfect. So let's move ahead to the last problem, I guess. So the next problem is really lovely. Okay, I love this problem because this problem has a really interesting connection to the billiard boards. Okay, so there's something in higher mathematics called dynamical systems. So this problem is really sort of in sense, like it's just, you can think it of as an infinite mirror problem. Okay, I like this problem. So let's see this problem together. Okay. So it's a geometry problem. So let's move ahead. So given a pair of concentric chords, guys. Yeah, sure, go ahead. How b is less than equal to 0? For a is equal to 0, b must be less than equal to 0. Otherwise, x square plus b, if b is greater than 0, then it implies that x square plus b is greater than 0, since x square is positive and non-negative. So therefore, this can never have solution if b is greater than 0. And is equal to 0 can never have solutions. That's the idea, okay? So let's do this problem. A pair of concentric circles chord AB and, okay, let's see the diagram now. Got the diagram. Perfect. Very good. Lovely diagram. So given a pair of concentric circles A, B, and so this is a pair of concentric circles. Okay, so you can think of it this outer circle as a circular mirror. Okay, and this inner circle is an opaque object where you cannot do it. So therefore you're lighting a source of light from here, just kissing the surface of the inner opaque object. Okay, you can think it of as the like what it's called, um, large hadron collider. Okay, so and you can think it of like that. So a proton beam is being projected from here, and it's going this and kissing the surface of this, and again it will kiss the surface of this somehow. Let's try to draw it together. Let's try to draw it in this manner. So it will try to be kissing here somehow. Let's see here. Okay, and then again it will be going to that side, and then again it will be going to that side, and it will coming back. Okay, so the question is that how many chords. So essentially you can prove essentially, so it can be very good generalization over here. Okay, that will be done in superstars classes. So please take note down of the notes, this like Yeah, exactly. For 60, it's very obvious. 60 is there. Okay. This problem is really, really interesting. So, Adip, we will do the generalized problem for theta. Okay. For which theta is actually this can be drawn. This can come back to the initial position. Okay. So there's a you can really do this problem for which theta it will come back to the initial position. Okay. So think about this. Okay, we can easily generalize this problem. Let's see over here. Um, um, it's a really interesting problem. Okay, so now it come back and it will come back again over here. Okay, so what we will do is that there is something called invariance. Okay, so what is invariance, guys? So invariance is something that is not changing. So we'll see that actually these two cause something invariance over here. Okay, so we will see that. So let's do some mathematics now. Okay, bit of geometry mathematics. So if you just what we will show is that what is your intuition, guys? If you just see something, it seems like this angle is same as this angle, okay, and this angle is same as this angle. It seems like all the angles are equal, okay. It seems like so, right? That's the intuition you get it. So intuition is really important here. So if you see all the angles equal, let's try to prove it. Okay, you have something in intuitive mind, and let's try to prove it. Okay, that's the idea. It can be related to a star, Mathian. You are right. You're right. It can be related to a star, but the idea is that um yeah, it's related to a star, but yeah, it's much more complex star over here. Okay, so let's consider this 75-degree. So let's consider general theta. Okay, and do this problem. So what we will do is this following. So we'll calculate this angle. Okay, so also if you calculate this angle, then this next will be in a recursive format. Okay, so let's not do into that. So let's first do this. Let's take this one. Okay, all these are radius. Okay, so all these angles are these are equal, and observe that this is equal, and we will show that this is equal to this is theta. Okay, so what we can show over here, how we can use the mathematics. So you can show that using RHS in this two using RHS in these two triangles. If you draw these two triangles, I will mark it slowly. If you draw these two triangles over here by RHS congruency, okay, you can show that these two triangles are congruent, and this will imply just at that moment that these two are angle bisectors, and once these two are angle bisectors, it will imply that these two are also angle bisectors, and this is in fact equal because it's isosceles. These two are also angle bisectors, and similarly you now use this triangle and this we have used this triangle and this triangle to prove these two are angle bisectors, right? Similarly use this triangle and this triangle over here now to prove that these two are angle bisectors. So therefore all these angles are equal, it will turn out. So therefore these are all equal angles, so it will imply that this angle is equal to this angle. Did you understand the solution, guys? So what will turn out that this two all this it's turned out that what we have shown over here is turned out that these triangles are equal. Okay, so during the exam you need not think much, but you should use this opportunity out to think deeply about this problem, because you may not know like what you're thinking may like turn out to be a really interesting problem afterwards. So observe that what does it mean to come back to the starting point. It's then again it's 75-degree by the same logic. Since this is 75-degree and this is 75-degree, this must be 75-degree and this must be 75-degree, and it's just turned like just comes here, it will be 75-degree. So when it will come back like this, what does it mean to come back like this after some point? Observe what is really happening over here. Understand this very carefully. What is really happening? So consider this in a different way out. Okay, so just focus on my words now. It's really important now. So consider this as an arrow. Okay, consider this an arrow like a clock. Every time it's rotating, what angle? A different angle. What is the angle it's rotating over here? It's 75 degrees, 75 degrees. You know these two angles are equal, so it's 37.5 degree, 37.5 degree. Therefore, it's 105 degree. Okay, it's rotating by 105 degree like this, right? It's rotating like this. Similarly, again, this is rotating, the next angle is rotating by 105 degree. Okay, rotating by 105 degree. Oops, I clicked the wrong. Again 105 degree, and again it's rotating by 105 degree here. So it's rotating like this again. Again it's rotating like this, and again it will rotate by 105 degree like this maybe, as you know. And again it will start rotating. So it will come back, means that after some rotations, okay, after some rotations, it will come back and follow. So when it will come back, when it, the rotation angle, the angle of rotation is some multiple of that n times 360 degree, right? So it will come back only when the angle of rotation, the total angle of rotation is a, yeah, exactly, is a multiple of this 360 degree, right? The total angle of rotation. So every time it's rotating by 105 degree. Okay, so we are trying to find an m, how many rotations minimum m, such that this is becomes a multiple of 360 degree. Okay, we are trying to find this minimum angle rotation m. Okay, so therefore observe that m is coming out to be n times 360 degree. So m, this is by 105 degree. So let's see what is. So if you just divide it by 5 and 3, 15, so it's coming out 3 and 5, it's coming out, coming out 2 and 6, that is 4. Here it's coming out 7, I guess. Yes, so it's m is equal to n times 24 n by 7. So observe that for this to be a multiple, m to be the smallest positive integer, n must be divisible by 7, so n is equal to 7. That means n, 7 rotations must be there. Okay, 7 rotations must be there, and observe that each chord is m, so m is therefore 24. Okay, that's the idea. The m is therefore 24. Okay, that's the idea. All of you understood? It's a really interesting problem. But my question is to you guys that so don't take this as just a problem for the exam. So think about, if what if the Large Hadron Collider was, so what if will be the angle? So understand that what will be the angle here, okay? What will the angle here? So there are two possible problems I can make out of this problems for you to try, okay? I will make two problems for you instantly to make you try. So the first problem is that, surely please take down this problem. This is really easy actually. I think it's really too easy for superstars. So if this angle is theta, okay? If this angle is theta, then how many such turns it will take? So if this angle is theta, observe this angle will be 180 degree minus theta. Okay, this middle angle. So 180 degree minus theta times m is equal to n times 60 degree. So therefore m by n must be equal to 360 degree by 180 degree minus theta. So this proves that if theta is irrational, it is never possible to return. For example, does the angle be pi or maybe root 2 degree maybe, okay? If not pi, maybe root 2 degree. So it is in degrees, okay? Remember that. If the angle is irrational, it may not be possible even. Okay. So if the angle is rather irrational multiple of pi, it's never possible. Anyway, so if the angle is it is never possible to return. That's the idea, beautiful idea. Okay. So just don't always do the problems, do a generalization of it. Okay, do always explore the problem, always. That's why I'm like using this opportunity to generalize the problem as much as possible. So it's never possible to return to the initial position if the angle is angle is an irrational number. Okay, now the idea is that, so I already proved it, okay, that if theta is irrational, then it's not possible. So prove it actually. If theta is irrational, it's never possible, okay? You can easily prove it. And prove that if theta is, so find out that if theta is any rational number p by q, okay, what is the possible m out here? What is the possible rotations required? So just put m by n equal to 360 degree 180 degree minus 360 180 degree minus p times it's sort of this. So you can find out from here that essentially it will be like whatever. I mean, you can find it out from here. Essentially, it will be this by the GCD of these two. Okay, so you can easily find out. Okay, you can easily find out what will be there. What is the corresponding part? So n essentially m is what? M is equal to 360 degree q by 180 p 180 q minus p, right, times n. So what you are getting over here is that you take the GCD of this, so you divide it by the GCD. So essentially n must be equal to the number of n must be equal to 180 q by p by divided by GCD of 360 degree q comma 180 degree q minus p. Observe that 180 degree q minus p, and this will have actually okay, it can have, okay, so this is the n you are required. Okay, now you can put and find out all the possibilities, and observe that this is the n required, and you can find out similarly the n. Okay, similarly, very easy, very beautiful stuff. I love this type of problem. Yeah, the angle can be obtuse. That's the next part. That's the next problem I'm coming towards. Okay, the angle can be obtuse, yeah, but it depends upon that's the next problem I am making it for you. The next problem is that if you sort of make the problem the two, so now it seems like it can be an obtuse angle. Okay, so now the question is that instead of finding in terms of theta, find for which radius. So let's say r1 it is, and let's say this is r2. Okay, and let's take any point, just kiss this part and just take it from here. So find this angle in terms of r1 and r2. Exercise 1, find theta in terms of r1 r2. Find the set of r1 and r2 for which theta is rational, that is for which it will return. You understand, guys? Because for theta rational it will only return. So you can easily find out by some trigonometry over here. Okay, so this is, I think this is r1. It's really easy, I guess. So this is r1, this is r2, and this is r1, and this is theta is what? Theta is equal to, theta by 2 is equal to, I mean tan of, sorry, not tan, this by this, height by hypotenuse is sine of theta by 2 is equal to r2 by r1 by r2. Okay, so find that, so when theta is irrational, so that's the rational, that's the idea, that is sine inverse, yeah, that's the idea. You can easily find out from here. Okay, it's a really beautiful problem. So you can find out, therefore, the problem boils down to the fact that for which values of r1 and r2, rather it boils down to the fact that for theta rational, what is the range of r1 and r2? Okay, like what is the range of values of sine theta? Okay, that's the idea. For theta rational, that's the idea. Okay, very beautiful problem. I love this problem, guys, and it's really beautiful problem. Oh sure, Amit, I will tell you that angle of rotation is, see, the idea is that if it's rotating, I told what, every single time it's rotating by an angle, certain angle. Okay, every single time it's rotating by 105 degree, so it will come back to the initial position if and only if the total sum of degrees of rotation is a multiple of 360 degree. Okay, 360 degree is one turn, then another 360 degrees. So we are required to find that when the sum of all the angles is actually 360-degree multiple. Okay, that's why it comes back to the initial position. Okay, so this is a real life problem. I think you can try it out. So see, I will tell you guys, if you want to enjoy mathematics, okay, so don't always think about exam, and let's think about the problems in terms of the exam perspective. Okay, as you can see, if you generalize the problems now, you can make problems for the next IOQM. Maybe your problem is coming up next the next IOQM, who knows. Anyway, so yeah, I will let your doubts in doubts, guys. Otherwise, I will again continue for the problem number 12 from the next day. Problem number 12 is a really interesting problem. Problem number 13, sorry. Sure, Amit, tell me the doubt. Which angle? Oh, it is given, guys. This angle is given. 75 degree is given. It's given. Okay. Okay, guys. Okay. Bye bye, and see you the next day. I love discussing these problems to you with you. It's not like discussing the solutions. It's much more than that. Okay. Okay. Which one then? Which 75 degree you're talking about? The other angle 75 degree. Oh, we proved it, na? Please see the recording, Amit. We proved two congruency. We proved two congruency over here, and we proved that that must be 75 degree. We proved that this triangle must be congruent to this triangle. Please see the recording and understand. Okay. If not, we will try it. Okay. All the best, guys, and see you in the next class. Bye. Sauradeep, if you're here, I would love if you can send me the problems. Okay, anyways, the problems are not really important, but yeah, send me that median and mean value problem, okay? So as a generalization of that median problem. Okay, bye-bye.